By the end of this module, you should be able to do the following. Describe how the brain auto-segmentation algorithm works. Identify the dataset requirements for the algorithm. Identify which VOIs the brain auto-segmentation algorithm can generate and observe the workflow steps. Specify various options to display segmented VOIs. Explain the editing features using this algorithm. Click on one of the following topics to begin the course. We will now identify the specific dataset requirements for running the Brain AutoSegmentation program. Brain AutoSegmentation requires a T1-weighted MR dataset. The system will automatically recognize when a T1-weighted MR image, in addition to the patient's planning CT image, has been loaded into the Precision workstation. The CT and MR images must be fused in order for the brain application to be enabled and selected from the Anatomic Region button from the Contouring task, Auto-segmentation step. Since the system requires T1 fused data, the system will advance the user to the fuse task following the load procedure. The accuracy of structures delineated by the algorithm is highly dependent on the quality of the T1 dataset, as well as an excellent fusion. Brain auto-segmentation accuracy is directly related to gray-white matter contrast, in addition to noise and resolution. The higher the contrast, the better the expected accuracy. From your introduction to the fusion tasks, you'll recall the system has the ability to perform both rigid or deformable registrations. We strongly advise that only a rigid registration be utilized for the brain auto-segmentation application. The primary reason why rigid registration is preferred is the fact that the CT scan has limited intracranial contrast, that is, it is difficult to see brain structure in CT, which could lead to introducing undesirable deformation to the MR dataset. For this reason, although it remains an option to override and use a deformable registration, this module will not address doing so. If chosen to proceed in this manner, the system will present the user with a warning that the deformable registration has been selected for use. For more details regarding deformable registration and/or selection of an alternative secondary dataset to run this application, you should return to the Fusion e-learning module. Let's get started with the process. We begin by selecting our patient and select Standard Plan. Load the desired datasets, specifically the two required, which include the primary CT and the T1 weighted MR. If other secondary datasets are desired for other purposes, we need to bring them in now. A maximum of 3 MR datasets can be loaded, fused, and available for planning purposes. The system will default to showing the T1 weighted MR dataset when entering the brain auto-segmentation step. The algorithm uses whichever dataset is shown on the screen when the user presses Auto-segment. If the user switches to the T2 weighted dataset, after entering the auto-segmentation step, the algorithm will end up using the T2 weighted dataset. As mentioned previously within this module, the best results will be achieved using a T1. If, however, the user elects to proceed using a T2 MR, a warning message will be raised and the results will be very poor. A significant amount of editing would be expected. Note, however, the brain auto-segmentation algorithm can be run at any point in time throughout the planning process. Use of the brain auto-segmentation template is not required. However, it is highly recommended. We advise you select it from the template list. Click Next and select to use template. As expected, we arrive in the fusion task. We perform our CT-T1-MR fusion now. We can always return here again later to perform other fusions. We would evaluate the results of the fusion and make adjustments as needed. There are 157 possible critical structures that the algorithm is capable of generating, which the planner can choose from. This library is extensive and intended to include functional areas of the brain in order to help clinicians make sound decisions to minimize dose within these areas whenever possible. The use of a Brain AutoSegmentation template is not required. If, however, the Brain AutoSegmentation template was chosen, the customer can alter the VOI names using the Properties button in Contour Task. The system is capable of segmenting as many as 50 VOIs from the all-inclusive selection list. The user designates the desired structures to be contoured from the Setup button drop-down list. Be mindful that the system has a limit on the total number of VOIs, which is 62 in total, that the planning system can accommodate. Critical structures generated will fill these VOI spaces, so we need to be mindful to leave spaces for our targets and any other special VOI, planning VOIs, you wish to create for planning purposes. Now we advance to the contour task. Once here, we need to select the auto-segmentation step and identify which application we wish to run. In the anatomic region box, we will use the drop-down and see 3 choices. As we mentioned previously, as long as the system recognizes a T1-weighted MR, it will give us the option to select brain. Similar to what you have already learned in our other auto-segmentation e-learning module, we can be ready to generate VOIs in 2 easy steps. We need to use the Setup button in order to make our VOI selections from the Structure VOI list. This is easy. As soon as you place a check mark next to the desired structure, the system will automatically name match or map that same name to the VOI. If you use the Select All checkbox, all VOIs will automatically be name matched or mapped. In the event that you prefer to not use the system-applied name, by clicking within the VOI name column, you will open the Select VOI list or template list that the plan was loaded with. Here you can reassign any name to the structure you prefer. There is no additional user input required than that. Click the Auto Segment button. Once you have done so, you will see in the lower left corner of the display area the message of Running Auto Segmentation. The run time will be dependent on the number of VOIs you requested, but on average, you should have your results in about 3 minutes. Once the algorithm has completed generating the VOIs, proceed to take a closer look at the results. You can use the VOI and display subtabs to enhance the VOIs for review. We should point out that the same subtabs, VOI and Display, which enable you to alter your layouts and/or make display choices for VOIs, are available within the auto-segmentation step. They work exactly as we have described during previous modules: head and neck and prostate auto-segmentation, contouring and/or visualization e-learning modules. Alternatively, rather than choosing to change a subtab, you can use the right mouse click functionality option to zoom the image to view the results, or select the axial side-by-side layout, which will allow you to observe the results on both the MR with the CT side by side. Recall from the contouring e-learning that you must be completely satisfied with the appearance of the structures on the CT. This is what the precision system will use for optimization and calculation. If not satisfied, you can repeat the auto-segmentation for that VOI and/or return to the fusion task if necessary. By now, you have likely noticed there are no editing tools within this step. If you need or desire to make edits, you must move to the contour task. On the manual step, we will select the drawing tool of choice and select the VOI to edit. Make all edits as needed or desired. There are a couple of very distinct and important differences you need to be aware of within the Brain AutoSegmentation application. First, once contours have been segmented, all edits must be done on every 2D slice in the manual task of the contour step. These tools have been addressed in the contouring e-learning module, and we encourage you to refer back to that module if needed. Second, edits for this application can only be performed in the axial plane. Once all desired edits are complete, we need to perform a final save of our contours. Notice when saving in an auto-segmentation application, there is a message within the Save dialog box that requires your acknowledgement for all VOIs that have been generated in an automated fashion. The system lists those that were created in this fashion. This acknowledgement must be clicked at the point of a save for any plan that you want to make deliverable. Having completed this e-learning, hopefully you feel very well informed on the options and benefits of the Brain AutoSegmentation application. You have observed the complete workflow for generating numerous normal brain structures in a few easy steps, in approximately 3 minutes' time. By now, your familiarity with contouring tools within the precision system will prepare you to make any desired or necessary edits to the VOIs that have been generated. We hope this e-learning has prepared you to utilize this highly specialized functionality. More importantly, we hope you recognize the benefits of choosing to utilize this feature. We believe it will provide physicians with the ability to evaluate dose statistics for more critical brain structures, particularly functional regions within the brain. If these VOIs were requested and had to be drawn manually, it would be very time-consuming, if possible at all.